on the other side of the ocean. But where to start? The best view of the entire Indian Ocean is from above. A weather satellite clearly shows the surface of this puddle, but what lies beneath? Should you start at the eastern part or the western? In Africa or India? It's all a matter of perspective. Scientists often look at the relations between the surface and the bottom. In fact, conditions above, on top, and also within the water mass. Actually, the oceans look like the mirror image of the continents. Troughs resemble inverted mountains, and flora and fauna continuously adapt to depth or to height, respectively. Politicians, from their viewpoint, look at the role governments have or should have concerning the cooperation of organizations and enterprises that, for instance, monitor the ocean conditions. Economists, in their way, search for the best and fastest way to develop agriculture, fisheries, and mining. Naturalists are more interested in the effects man has on his surroundings. As a citizen, on the other hand, you want to be informed of the effects the ocean has on your own life, whether you're in Africa, in India, or in Western Europe. What's the latest news? News. That's what really counts. But that means exploration. The Indian Ocean Expedition has been searching for answers to a number of vital questions addressed at the ocean day after day. Literally, an in-depth interview. Suppose you already own a research vessel here named Tyro. The problem then is, you need answers to not one, but to over 50 questions. To each problem, however, there's a solution. In this case, you translate each question into one or more experiments and set them in a container of their own. These containers are brought up on deck from within the ship when there is time to conduct the experiments. Monitoring currents is an important aspect of ocean studies. Mapping all these currents gives an image not unlike the ones used in making weather forecasts. Ocean forecasts, short as well as long term, are needed to take the ever-shifting climate into account. Similarly, a container can be placed on land should experiments so require. It's an efficient way to get all your research organized with limited time and limited space. This method is still being optimized for future use.
Nou, zo helpt. Wat komt er een lucht uit die flessen naar boven?
These predictions are based on large numbers of data updated daily by ocean measurements.
Stop!
Nou 50 meter op, naar 150. Ja, stop maar.
Verstopt.
Meter op naar 100.
Instead of launching a weather balloon, equipment is let down to the bottom of the ocean to take daily measurements, sometimes for as long as half a year. After those 6 months, you just come by, press the remote release button, and pick up the equipment. As seasonal weather on land can largely influence agriculture, so the monsoon hampers fishermen at sea. Still, there are recurring patterns here, which we can detect in the depths of the ocean. Natural phenomena are often indicated by prior changes in ocean flora and fauna, or by obvious water movement, as during upwelling. Frequently, plankton bloom turns the water green or sometimes even blue or red. Samples are taken and studied in the plankton container. Why? Well, planktonic organisms are eaten by fish, and fish are eaten by man. The Tyro brings us all over the Indian Ocean. The scientists can't wait to get a good look at the reefs. Below the surface, you get a really awesome view of how much space the oceans hold. Data gathered below the ocean surface tell us more about global patterns, the Earth's system. Mapping the ocean floor is an important method for studying this system. The easiest part of the ocean floor to study is where land and water meet, the seashore. Territory is very important on that narrow interface. The majority of the world's population lives on or near the shore. Still, we know less of the sea than of the land, which in some ways is quite surprising. On the other hand, it isn't easy to have a network of manned monitoring stations at sea, similar to those on land. Incidental surveys of the ocean only give isolated impressions, but frequent sampling will eventually provide an understanding of the processes within this huge body of water. These processes are of relevance to many of the sciences and therefore to scientists. Mainly studied through the international cooperation so typical of science and in fact a prerequisite for political backing. Cooperation means more efficient use of equipment and sharing results. Results from frequent observations, well analyzed and widely published. We must keep questioning the usefulness of proposed studies. Should we, for instance, concentrate our studies on the number of species there are, or perhaps on trying to identify new species, or studying those on the verge of extinction? Identifying natural phenomena and their interaction is not only an intellectual challenge, it's also of vital importance. Being able to forecast changes in currents, and therefore fishing grounds, has a direct impact on one of the basic needs that still remain uncertain for a large part of the world's population, namely food. Furthermore, should we determine the rise of an atoll relative to its surroundings, or rather the change in global sea level? In all cases, careful measurements and analyses are in order. In some cases, equipment is shipped in by the ton, by the container rather, to solve certain mysteries. For example, what was the climate like 1 million years ago? This usually involves drilling the ocean floor for layered samples that might give us answers. A large drilling device is lowered from the ship. Here, completely different techniques are used as compared to the more detailed and often chemical lab analysis. Still, by well-organized and targeted cooperation on board, results are produced in a matter of hours. To read the diary of the Earth, however, you have to break open the cover. A muddy core of Earth's history, like this one, contains chronological information about the volume and scale of the ocean, and also historical data about fluctuations in ocean climate. These samples yield information for years and years, in particular to compare with future experiments. It's important to keep in contact about research methods, results, and well-agreed protocols for joint action. No matter how different some cultures appear to be, they all have the same vital objective. A healthy ocean is a must for survival. Real cooperation, so to speak, and that requires an ongoing dialogue. And not only in the geographic areas, but the political ones too. Government organizations must be made aware of and become convinced of the need for continuous surveys.
Of the oceans and their resource in world politics and sustainable economic development.
So researchers should operate on an international level and speak the same lingo.
You have a lot of crossover points. Okay, we're talking about crossover, and the discrepancies, the crossover discrepancies from bathymetry are usually caused by navigational inaccuracy.
The sharing and passing on of skills and knowledge is paramount in setting up a global network to monitor the ocean conditions.
Surveys on shelf
Global
regions,
meaning in all four corners of, in this case, the Indian Ocean. Being able to get the need for research across is as important as the research itself. We need to be aware of the viewpoint of politicians, economists, naturalists, and ordinary people, and present our case accordingly. At least if we want to set up a vigilant and lasting workforce for research. On all sides, and especially on the other side of the ocean.